For this lesson, we talked about shadows and how they create similar triangles. So that's our goal. How do these shadows create similar triangles? Well, first let's review. When we have similar figures, the corresponding angles are congruent. So angle D matches up with angle A here. They're both 30. C matches up with F. They're both 45. And remember, if two angles are the same in a triangle, the third one has to be the same using triangle sum theorem. We know they got to add up to 180. So 180 minus 45 minus 30. This angle's got to be 105. And then using the triangle sum theorem on this triangle, it's the same exact problem. So this one is also 105. So all three angles are the same as long as you have two the same. So if we look at a shadow problem, right? There's some sun, there's some people, there's a lamppost, there's shadows. How are these triangles similar? Well, one, when you stand on the ground, you're creating a 90-degree angle. You're perpendicular to the ground. Unless you're leaning, as long as you're standing up straight, you are perpendicular to the ground. Then the sun's in the same spot in the sky for both of these. So the sun is coming in at the same angle as well. Since these triangles have the same two angles, the third angle is going to be the same, which means we have similar triangles. So the sun comes in at the same angle, the people are perpendicular to the ground, therefore all three angles of the triangle have to be the same. So even though these shadows are getting bigger longer in the day, they're getting bigger for everyone. And the mailbox, the shortest figure, always has the smallest shadow. The person has the middle, the lamppost has the longest. At night, there's no shadows, fun fact. But it's always proportional. So we can use these things to set up, or similar triangles, to solve missing sides using shadows. So for example, in this problem, we have the height of a lamppost is 15 feet. I'm just going to label what I know. 15 feet. And the shadow length is 6 feet. So that's a right triangle with a 15 height and a 6 shadow. What is the height of the tree if the shadow of the tree is 20 feet? So let's figure this out. We know there's similar triangles, so we can use a proportion. 15, the height of the lamppost divided by the shadow. 15 over 6 equals the height of the tree divided by its shadow. It's got to be proportional. And we're just going to cross multiply here. 6 times h is 6h. 15 times 20 is 300. I just did this problem, that's how I know that. You could use the calculator. Then to solve for h, we're going to divide both sides by 6. So 300 divided by 6 is 50. So the height of that tree is 50 feet. So we're going to fill that in real quick. 50 feet. Now let's find the height of the minaret, basically a big tower. The shadow is 56 feet. Now, just using some proportions here, 20 to 56, that's almost 3 times as big. So this should be pretty close to 150 if I'm just like making an estimate in my head. 20 times 3 is 60. So it's pretty close to 3 times as big. So it should be a little less than 150. But let's figure it out. So I don't know the height of the minaret. I'm just going to call it M, whatever. I could use the 50 and the 20. I could use the 15 and the 6. I'm just going to use the 15 and the 6 again. So 15, the height of the lamppost divided by the shadow, equals, now I got to make sure I do the height again, the height of the minaret. So let's call it M, divided by the shadow. So we did height over shadow, so let's do height over shadow again. 56 is the shadow. And now we're going to cross multiply and solve. So we have 6M equals, and we're going to do 15 times 56. That's 840. Now we got to get the M by itself, the height of the minaret. We're going to divide both sides by 6. So 840 divided by 6. Oh, it's 140 feet. So let's see if this works. M equals 140. All right, let's check our work here and see if we got this correct for these triangles. Yep, it's 140 and 50, and these three triangles are all similar.